Hello students. Today we're going to start a next chapter, that is alkyl halides. So in this session we will going to discuss. Before that, these are the contents in from this chapter. One is the introduction, classification, nomenclature of alkyl halides. Then isomerism occurs in the alkyl halides. Preparation of alkyl halides. There is a various methods are available. Physical properties and chemical properties of alkyl halides, and last one is the fluoroalkenes. So the first one is, the haloalkenes or alkyl halides are the compounds formed by replacing one or more hydrogen atoms in alkanes with halogen atoms, right? So they may be mono, di, tri, or tetra, etc. Okay, and haloalkenes, depending upon number of hydrogen atoms replaced or substituted by the halogen atoms, right? So we can say halogen derivatives they are the halogen derivatives of hydrocarbons, and they have a general formula CnH2n plus 1 X. So X is nothing, it is a halogens. It is fluoride, chloro, bromo, iodo, fluoro, right? And it is also known as haloalkane, and it is represented as Rx. The CX bond, right? The CX bond means the carbon halogen bond. They impart polar in nature, and before that, in haloalkanes, the carbon halogen bond is formed by sp3p overlap between the alkyl group and the halogen group. Being more electronegative compared to carbon halogen impart a polar character to carbon halogen bonds, where the halogen acquires the negative charge, and carbon acquires charge positive. Okay, so that is so as the size of the halogen increases from fluorine to iodine, the carbon halogen bond length increases and bond dissociation strength decreases. Okay, so these are the given what we say data for the different halomethanes. Tertiary alkyl halide. So basically, in this case, in these halides, the halogen atom is linked to a tertiary carbon, that is a 3-degree carbon atom, which has no hydrogen atom present. So in short, so this classification is based on bonding pattern of carbon bonded to the halogen atom. Halogen is used, right? So that is based on what type of carbon, whether it is a 1-degree carbon, 2-degree carbon, and 3-degree carbon. Yeah. Another classification is also based on the number of halogen atoms, right? So how many halogen atoms are present in the structures? So they contain 1, 2, or more halogen atoms in the structure. If it is one halogen atom in the structure, we call it a monohaloalkanes. If it is two halogen groups are there, we call it a dihaloalkanes. If it is 3, it is called trihaloalkanes. So that is the classification of the haloalkanes. Then we discuss the nomenclature of the alkyl halide. So basically, the common name is basically derived by naming the alkyl group followed by the halide. So that is alkyl plus halide will come into the picture. And the second one is the IUPAC system. So they are called haloalkanes. So these are called haloalkanes in which halogen is a prefix, and it is prefixed to the name of the alkenes. So simply we can say this is IUPAC name format. The first is the locator number, so where is the halogen atom is present. Then halo prefix will come, that is the chloro, bromo, iodo, fluoro, etc. Plus the parent alkenes. Okay, so that in this way we can do the nomenclature. Then again, the alkyl halides can show the many isomerism, like important are like chain isomerism, position isomerism, and optical isomerism, right? So basically in the chain isomerism, so this is due to difference in the arrangement of the carbon atoms in the chain, right? This is only purely because of the arrangement, how the carbon atom is arranged in the chain, right? So that is the chain isomerism, that will, right? And second one is called the position isomerism. So this isomer differ in the position of the halogen atom, right? So that is the position. And third is important, that is the optical isomerism. So the certain members of the halogen family have tendency to show optical isomerism, right, which is a stereoisomerism. Okay, and it is exhibited by optically active substance. Okay, so basically the optically active substance generally exists as a pair called optical isomers. One being dextrorotatory, that is a plus or small d, and other is a levorotatory, that is a minus or small l. So what is dextrorotatory? The one which rotate its path to the plane polarized light to the right, that is called the dextrorotatory, and the other which rotate plane polarized light to the left, called the levorotatory. So that is a plus and minus. And the question of which type of isomers, right? Basically such substance has at least one chiral carbon, and both isomers are non-superimposable mirror image. Okay, and normally they are called as the enantiomers, right? So that we'll discuss in our third chapter, that is the stereochemistry. Okay. Now the next one is the physical properties of haloalkanes, right? So they show show the physical properties like the bond strength, right? The bond strength. Then it comes to the solubility and state of matter, then boiling point and density, right? So we already discussed that the bond strength, right? So basically in haloalkane, bond strength of carbon halogen bond decreases with an increase in bond length, right? As we move from fluorine to iodine. Okay, so that is the one. The second case, the solubility and state of matter. Basically these are they are insoluble in water but soluble in organic solvent. And the low molecular mass alloalkanes are gaseous at room temperature, and while the higher molecular mass are liquid at room temperature. And the fourth is the boiling point. So the boiling point of alloalkane is higher compared to the corresponding alkanes due to the weak one-to-one forces, that is the dipole-dipole interactions. Okay. Then density, yeah, the densities of haloalkanes increase with atomic mass of the halogen and decrease with increasing size of the alkyl group. So in monoalkanes, the iodomethane has the maximum density. Or if you look into the characteristic of the monoalkane, the fluoro and chloroalkanes are less dense than water, whereas the bromo and iodoalkanes are more denser than water. And monofluoroalkanes are unstable on heating, so that is HF is eliminated to produce alkene. Third one is bromo and iodoalkanes are generally photosensitive and are stored in brown opaque bottles. Otherwise, they liberate free bromine and iodine respectively. So that is an important characteristic of the monohaloalkanes. Okay. Now the preparation of alkyl halides. So the various methods used for the preparation of haloalkanes are discussed in this session, right? Some of the method for the preparation of haloalkanes already discussed in the previous chapter, but whenever it will come, definitely that will show in appropriate places, right? So the first one is by halogenation of alkenes. Right, so basically the direct halogenation of alkene in the presence of light, heat or catalyst, right, result in the formation of haloalkanes. Okay. Then second one is by addition of halogen halide to alkene. So basically it is the electrophilic addition of halogen halide to alkene, which we already discussed. The Markovnikov rule and the peroxide effect will come into the picture. Right, we already discussed. Third one is from alcohol. Again, the alcohol, there are two reactions are there. One is by reaction with hydrogen chloride or hydrogen bromide, right? It's important, right? So in this case, the reaction of alcohol with HCl in presence of some zinc catalyst result in the formation of chloroalkanes, right? That we'll discuss. Second reaction by reaction with some few reagents like phosphorus trichlorides, phosphorus pentachloride, and SOCl2. But SOCl2 method is being the best method, best method for preparation, since because the byproduct is sulfur dioxide and hydrochloric acid being in the gaseous state, so can be removed easily. So the reaction can be best one compared to the other PCl5 and the PCl3. Okay. Then another reaction is from other haloalkanes. So that is in this case, the first one is the formation of iodoalkane. So the two reactions are there. One is the halide exchange and via Grignard reagent. Okay. So second one is a formation of fluoroalkanes. It's a name reaction that is called the Schwarz reaction. Yeah, in the previous the formation of iodoalkane by halide exchange reaction, it's a very good name reaction that is called the Finkelstein reaction. Thank you.